Now, just now before the breaks, we have looked at example 1. Example 1, you can also get the same answer for V2 and N using chapter 2, chapter 3 equation. Okay, you can solve using chapter 2, chapter 3 equation, or the force equal to MA, F equal to MA, right? F equal to MA in X direction or in Y direction. Then you use the Newton equation, V equal to V naught plus ACT. This one you learn in chapter 1 or chapter 2. Okay, when we derive the graph, the VT graph, AT graph, ST graph. Okay. V equal to V naught plus ACT. You can solve this problem by using F equal to MA and V equal to V naught plus AT. Just be careful. Again, in exam or test, there will be specific instruction given to you to use a specific principle. Okay. So in exam, if you're told to use principle of linear impulse and momentum, and you use this method, you won't score points. You won't score point. In your answer sheet there, I will write wrong concept, no marking. So means you score 0 point for that question, right? Or I will write something like, this student don't understand principle of that one, so get 0 point. So just take note on that. And very high chances that the question, I will combine chapter 1, 2, 3 and chapter 4 together in one question, where sometimes I will ask you to use what you learned in chapter 1 and 2, same scenario, but prove the answer in A and B with what you learned today. Okay, you use F equal to MA and V equal to V naught plus ACT, you find V and N. After that, you prove this answer and this answer using what you learned today. Okay. All right. Let's look at your second tutorial question. You're given this diagram. An object was moving from high ground to low ground at a certain angle. Velocity 1 meter per second going down with a external force of P pulling at this corner. And then you given some more information in a statement. You are given the mass of that object, 25 kilogram, acting on a force having variable magnitude. Again, your P now is having variable magnitude, where your P equal to 100 Tn. Okay, this is more near to engineering dynamics standard, where now we come to chapter 4, your force is now in the equation form. Okay, it no longer in the constant value. So in test or exam, this is one of the area where students make mistakes already. Okay, don't assume things. When you see something that you're not sure in exam, you can always ask the lecturer. Okay, does it correct or not? All right. Okay, so if you in this question, if you use 100 Newton, means wrong already. Okay, because it's your P equal to 100 T. It depends on the time. T is in second. It asks you to determine the crane velocity after 2 seconds. Right, velocity at 2 seconds after P is applied. So once the P apply after 2 seconds, what happened to the velocity? All right. So the initial velocity is given. So now the initial velocity is no longer at rest. It's given at certain value. Down the place and the coefficient of friction is given. Now you're given the friction is no longer smooth surface. So you're given a smooth friction constant 0.3. Okay, I give you 1 minute to give me the free body diagram of this object. Then you show me. Okay, 30 seconds. Look at this question. And then I'll ask one of you to capture your hand sketching, upload into the chat room, and I will see whether correct or not. Okay. Those watching YouTube, you can fast forward now this one until I discuss the question. Okay. Now I want you to draw the free body diagram for this scenario. Okay, in your hand sketching, in your free body diagram, include the positive direction of your axis. Okay. I'll call someone to show your answer in the chat room. You still have another 30 seconds. Okay, I'm going to ask Nageshwaran to show your answer in the chat room, in the meeting chat there. Snap your answer as a photo,
And can I have like another 20 seconds, sir?
Okay, can. All right, I'll give you maybe 1 more minute.
Okay, sir, thank you.
Right. Free body diagram. Ask you to draw free body diagram. I want to see forces. I want to see your axis. Show me your positive direction. Your positive. You can use x axis or y axis. You have to show me the positive direction of your x and positive direction of your y. And then you share, Nageshwaran, you share your answer to the chat room, and everyone can look at it. Okay. 1 minute is there, so Nageshwaran, you can upload your answer to the chat room. Just a simple sketch. You don't need to give me a very just take a photo on your hand sketching and you just attach. Can you attach? Let me see. Nageshwaran, can you attach the file?
So sorry, I put it in a WhatsApp group, sir. Do you want me to put it here?
Oh, you post in the WhatsApp, is it?
Yeah, sir.
Okay, all right, let me go and see it. Okay, yeah, I saw your message. Okay, I believe everyone is seeing the answer by Nageshwaran, yeah? Okay, I'm going to ask question. Sivendra, are you there? Sivendra, sorry for those YouTube on the YouTube. Yeah? Right. Okay, Sivendra, you look at the Nageshwaran hand sketching.
Yes, sir.
Is there anything missing in his hand sketching? In his
Yes,
free
sir. You
body
don't
diagram?
have the opposing force, which is Fr.
What is FR?
The force opposing P.
Or what is that?
Friction force.
Correct. Okay, right. Okay, Nageshwaran, do you see? Do you understand what Sivendra saying?
It should be
Yes, sir.
going the opposite direction of P.
Yes, correct. It should be under the object there. There is friction force. Okay, basically, your free body diagram is okay. But if you miss one force, means your solution later will have problems already. Yeah. Okay, this is just a early exercise for the class. So let's get back. I'll still give you the answer. Let's check. All right. So free body diagram, you draw the object, and first thing is your, again with your W, and in this case, my X and Y, I will follow the body of my object. All right. I will tilt all my axes along my object. Means I see this one as a body as on the floor, but I tilt my W to 30 degree. Okay, but either way it works. Okay, either way it works, because later when you solve, some people they confuse with angle, right? Okay, so this is the complete set of free body diagram. Your body. So in the test or exam, I don't expect you to draw a very detailed object here. You can use a standard box, rectangular, square to represent that one. All right. So start with W, and then if this body touch with the surface, they always have a normal forces, and the force given here is, of course, this one is P. It should be 200T here. Typo error here. It should be have 200T. Not sorry, not 200, 100T. But in this case, because I straight away solve it after 2 seconds. So when I substitute 2 seconds in the P equation here, I get 200 Newton. So this free body diagram is for 2 seconds. Okay, but if you draw in the more general form, your P you should write 100T. Equation here 100T, right? So in exam, either you write 100T, or you can straight away calculate the value magnitude after 2 seconds. Both correct. All right. So then the friction force, because again the question give you something, it means you need to use it already. So friction force is mu equal to NC. Unless you get a tricky question, it give you the friction, and then in one of the section of a question, it asks you to assume. Okay, A you solve lah. Then B section it asks you. It assume if you having a smooth surface, what is the differences of impulse, for example? If the floor is smooth and polished, smooth. So it use the word smooth, means second section, you draw the same free body diagram but without the friction force. And then you make comparison. Okay, so you need to be careful. Look carefully on the question. Normally, if the friction coefficient is given, you need to calculate the friction, right? Friction equal to mu times the normal forces. And the direction, again, it is opposite of your movement, of your object movement. So in this case, V is included there because I know I need to use the principle of linear impulse and momentum. So I just remind myself my object is moving that way. Okay. In normal free body diagram, there's no V there. Yeah, I put in V just to remind myself I'm solving using linear equation. And if this example 2 fall into chapter 2, chapter 3 question, you will need another diagram here. We call it kinematics diagram or kinetic diagram. So you can combine kinetic in free body diagram with the acceleration. Okay, so that is chapter 2, chapter 3 question. But when it comes to chapter 4, we're just interested in velocity. Okay, I put the diagram to right hand side. You already know how to plot this one already. So use the principle of linear impulse and momentum equation. In this case, we will use x and y direction. Okay, mv momentum before plus impulse because of the external force fx and the momentum after. mv1 plus sum of integration of ft equal to mv2. In this case, I put in x and y direction. Okay. So I'm putting, okay, in this case, my x is going down positive, means this is my x positive. Just to make me convenient to solve. This is x, this is my y. Okay, meaning I need to split my w in x, in y and x direction. The Raster substitution, you have your velocity before. After you don't know, you need to find. Right? You need to find. F you have. All right, F in here, but in the 100t here. Okay, 100t, and integrate with t 2 to 1. Right? So you put in the mathematics equation here. mv1 integrate 0 to 2 seconds. pt minus the friction force. Again, this friction force is also one of the famous mistakes. Student will forget about friction. So friction multiplied by time. Again, what is impulse? Impulse, force times time. As long as there's a force and there's a time, then impulse happen. Okay. So in the free body diagram, as long as there's a forces, W create impulse, this impulse, this one also impulse, this one also impulse. So you have P, T, force, friction force, time, weight, T, and my weight here is in X direction, sine, positive, this one, right? W, X direction, W, Y direction, W sine 30, T, and MV2, okay? Let me check now. Is that the connection there? You guys can hear me, right?
Yes, sir.
Okay, because the lighting in my room is suddenly shut off. I don't know what happened. It keep turn on and off. Okay, but anyway, let me know if suddenly I lock out from the system. Maybe the electricity power in my office is having some problem. So you just substitute the value there, right? So 25 is a mass in kilogram, velocity 1, P in 100t, and you need to do integration here. Again, T is integration here. So T, when you integrate, T squared divided by 2, and 0.3 is given, N 2 seconds, W 25, G sine 30 times 2, mass 25, and so on. So here you have NC missing, or the normal force missing, and the V2 missing. Okay. You rearrange, you get one equation. Okay, you rearrange, you get one equation. Okay, you rearrange, you get one equation. Then we go for y direction. Okay, we have clear with this principle of impulse momentum. Later we will look at y. We look at y. We will get another equation to solve NC and V2. Okay. But here we use equilibrium forces in y direction first. Just look at a free body diagram, and you balance all the force in y direction because we know that our crane do not fly into the air. It is in balance with the constant velocity, or not constant velocity, with the change of velocity. So we look at all the force in y direction. So your W, you have y pointing down, WY, and your NC. The rest is x direction. So here you have NC equal to W cos 30 equals 0. So you can find what is your NC, right? So you substitute the value. You have your NC equal to something. W, you know how to find already. Okay, so you substitute the value, you find your NC, then you substitute back to the equation just now, substitute back to here, you get your V2, Vx2. Vx2, you find one number and remember the unit. So from here, you already found your velocity after 2 seconds, but in x direction. What about another direction? Okay, so you can combine with equation of motion, F equal to ma, to solve this question, but in x direction. So F equal to ma in x direction. Then you balance all the force in x direction on the left hand side. Left hand side, all the force in x direction equals 0. So you have P, you have friction, you have weight in x direction here. So weight Wx here is positive, P positive, friction negative. Okay, P again you put in the equation, 100T, friction equal to mu friction coefficient times the n you defined just now, plus mg sine 30, m given, ax you need to find. Okay, so here this equation you can find the acceleration in x direction. Okay, your acceleration is in equation because you have a t there, right? Ax equal to 4t plus a constant value. And then recall the kinematics equation that we learned in chapter 2, dv equal to a dt, or a equal to dv dt. You just put dv, you put the dv in the dt to the right hand side. Why? Because this is the acceleration equation for this object, and we need to find what is the change of velocity from the initial until 2 seconds. Okay, this is another method. Previously, we already solved the V2 already. Okay, previously we already solved the V2 with principle of impulse and momentum. This one we solve using principle of impulse momentum, this equation in x direction, plus the equilibrium equation. Only get the NC and the velocity asked by the question. Okay, another method I'm showing you here is what you learned in chapter 2 or 3, right? Where you use using equation of motion. All the force equal to ma, F equal to ma. Then you solve using F equal to ma, and then you use what you learned in chapter 2 kinematic equation. dv over dt equal to a, then you do integration. Okay, dv equal to a dt, you write in the integration form, because when you again you see dv something, d something left, d something right, you can do integration. So you transform this one to integration form, integrate v1, already know, you know that v initial is 1, given in the question, somewhere in the question, right? Until the second v, dv equal to a integrate from time 1 to time 2. So time 1 is 0, time 2 is 2 seconds. You know what is your acceleration equation that you derive from F equal to ma equation. You put in your a inside here, dt. Okay, so you need to solve for your t here, integration. Right, t integrate become t2 divided by 2. Calculate, you get your v equal to 13.7 meter per second. Okay, same like what you find in using principle of linear impulse and momentum, but different method. This is chapter 2 or 3 solution. The one that I show you before these slides is principle of impulse and momentum. I hope you see the differences. And this is an application of same scenario but different equation. Okay, one you solve with the impulse and momentum, one you solve with the equation of motion. Okay, both get the same answer. Any question, for example, 2?
Yes.
Clear? Okay, let's go for one more and then we call it a day. You guys have class, right, after this?
Yes, sir.
Okay, let's look at very fast. Example 3, you see this diagram. You're familiar with this diagram already? Means pulley system. And one of the learning outcome or one of the things that the examiner look at is whether you're able to solve a pulley system or not, right? So if you look at a pulley system without reading the question, the first thing come into your mind, this one fall under this particular section or chapter in chapter 3 that we learn about pulley. There's a relationship between A and B. Okay, so when you have pulley system, always go back to the pulley system. We always link A and B with what? With the length of the cable. You link relationship of A, B with the length of cable. That is number 1 when you look at pulley system. Number 2, always have the datum. Okay, always look at the datum. Pulley system always give you a datum, and there will be a positive direction of datum. For example, A is measured from here going down positive. B also measure from datum going down positive. There are two things every time you look at pulley system. First is relationship between A and B using cable. Then from cable you convert into velocity of A and B. What is the ratio, right? That's number 1. 2, always have refer to the datum either going up or going down positive. Okay, and be careful every time you see datum, if it come into energy, potential energy below datum is negative energy. Just to recall, anything below datum, it gives you negative potential energy. Anything that above datum, it gives you positive potential energy. But this is just a recall for chapter 3. Okay, back to this chapter 4 question. You're having a pulley system and you're given some information. As you can see in your tutorial, you were given the mass 3 and 5 kilogram A and B. If the system is released from rest and you have this statement, you know the initial velocity, you're given initial velocity released from rest. Determine the velocity of block B. This one. Block B, this one after 6 seconds. Ignore the mass of the pulley and cord. right? Before you start, you try to logical think. A is 3 kilogram, B is 5 kilogram. If you release both of the object at the same time, you release A and B at the same time, can you estimate the motion of A and B? Right, just a quick question. If you release A and B, just a logic question. Release A and B at the same time, are you able to see the motion of A and B? Will the A move up or move down? Will the B move up or move down? Okay, have a thought on that. Of course, the heavy object will go down. So if this one go down, what happened to A? A will go up. Okay, so the opposite direction of A and B from the diagram itself, it tells you the velocity of A and B is a opposite direction between A and B. So later you will see the positive sign and negative sign for velocity of A and B. And you can see the datum here, positive going down, meaning if the A going down, later the velocity of A will be negative. Because if you let go of B, what happened to A? A will move up, right? What is the datum tell you? Displacement go down positive, but A move up. So later your velocity for A will be negative. This is just a cross check of your answer, right? If you get positive value for A, means something wrong already. Something wrong in your calculation. This is just a self-check. By looking at the diagram alone, you can do this analysis. So B will sure go down. So datum as B go down means speed of B go down will be positive. Mean if B go down, your velocity of B will be positive. The question asks you to determine the velocity of block B, right? So after you release block B, datum go down positive. So velocity B, you should get positive velocity for B. If you get negative, means something wrong with your answer. If you get negative velocity V, B go up because of the datum given. So these are the early analysis of your, before you do something, think whether you understand the question or not, right? Then you draw free body diagram. So you start with pulley, pulley of D, this one. Okay, you start with pulley D because you want to find the tension cable, the tension in the cable. So you start with pulley D here. You have two rope pulling up. So you have TB1, a TB2, or TB, same. But what is the tension cable pulling going down? It will be tension pulled by object A will be 2 TB by looking at this pulley system here. Okay, so there are two rope, means tension, one tension, two tension, but this one will be balanced by these two cable. So this cable is equivalent to 2 TB. Okay, so this one already covered in the pulley system already. Just the introduction again. All right. So from here you can link your tension A and tension B, object A and object B. Then you look at object A and B. A pull down by gravitational force, object A. So WA equal to mg. I just denote as m sub A, means to represent mass of A. Gravity will always same, 9.81. Same with B also. So above A, above object A, you have one cable pulling. So cable pulling you can write as TA if you want. If you start to draw free body diagram for object A, you can write this one as tension A, no problem. But all right, if it's good to have this free body diagram so you know TA equal to 2TB. This one I move fast a little bit. Huh? So this, how you get 2TB from this free body diagram. Where is this free body diagram represent? Pulley here. Okay. So you do the same for B by one cable here. This is cable B. So you already have cable B here. So you do the same for B, gravitational force pull down. Mass is different, MBG. This one cable pull up with a TB. So basically from this diagram, you should be able to draw the free body diagram. Even you don't draw this one, I still give you marks, but minimum you should be able to draw object A and object B free body diagram. Okay, this is just additional information to link this TA and TB. Why I substitute this TA equal to TB? I reduce one unknown in my calculation. I reduce finding the TA in my calculation, because once I know my TB later, I know what is TA directly. Okay. Any question for free body diagram? Important, in this module, the first steps always in the question, expect free body diagram. Your free body diagram correct, then the rest should be no problem. Free body diagram, you miss one forces, the answer will be wrong. Okay. Any question for this session? For these slides? Clear? Next, we move on. The next, I just add in the velocity just to remind myself I'm going to use principle of linear impulse and momentum. I just add in the velocity of A. In this case, I assume VA going down positive. Of course, in the real case just now, logic thinking, you know that your VA will be going up because B is more heavy, A going up. But in my free body diagram here, I assume all my object will be going down positive. So my VA positive direction is going down. Okay, why my VA I assume as going down positive? I follow my datum direction. I follow my datum SA direction. Just to confirm, I don't I don't confuse myself. I always follow the datum going down positive. So my velocity in my free body diagram also positive. Although in real case later I know my VA goes up. So when I later I will expect my VA answer later will be negative. Okay, I will expect my VA, my velocity of my object A will be negative because of my datum direction. Okay, VB also same. Pointing down. Why pointing down? I refer to my datum. SP positive going down. So from here, I label as VB. The direction of VB, I follow my datum. My SA going down positive, SP going down positive. So later, I will expect VA in my calculation. VA, I will get negative value. VB, I will get positive value. Okay. Before I go into calculation, this is my expectation. My mind mapping already see all this value, whether it's positive or negative. Okay, next you calculate about kinematics, that what you learn in pulley system. You link the length of the cable together. The total length is SA plus SA plus SP. So that's why in calculation here, 2SA plus SP equal to length, right? SA plus SA, you get 2SA plus SP. You get the total length. This you need to process further to find velocity and acceleration. How you find velocity? You integrate this one, differentiate this one with time. You get the ratio between A and B. Because length doesn't change over time, this one becomes 0. This one become velocity of A. This one become velocity of B. We already covered this one in pulley system in chapter 2 or chapter 3. So you have 2VA equal to minus VB, or minus 2VA equal to positive VB. Doesn't matter. From this equation, you know VA, VB opposite direction, which is correct, which is logic. Okay. In this highlighted VA and VB, you see a negative sign, positive and negative. It means A and B move in different direction, which is correct. So this is correct. Then you move forward. So if this one, this calculation here, if you get positive, positive, means something wrong. You need to check. Here, if the object that seems doesn't logic, then you need to check your calculation. In here, everyone check out. Everyone, every lines of calculation here, it approve the real scenario happen. So I pull all the information together and I put the relationship of VA and VB and look at object A for the moment. I pull the principle of impulse and momentum equation to analyze A. And I know that direction of positive of movement is going down positive because of datum given in the question, going down positive for A. So I just mark my positive direction going down positive. So you should have this equation, mv plus ft equal to mv. So mva1, which is before, sum of ft equal to mva. This one already explained before this break. So the rest is just substitution. It tells you it released from rest. So before is 0. Velocity for A and B is 0. Before the release is rest. Then what is the forces? Or what is the impulse? As long as in your free body diagram there is a forces, this one create impulse, this one create impulse. This one force times time, this one force times time give you impulse. There are two impulse there. So 2 TB is a force multiplied by time. What is the time? 6 seconds. And the weight of A is 3 kilogram multiplied by 9.81. T 6 seconds, mass 3, VA2. So from here, you have one relationship of TB and VA. Okay, you have one relationship, one equation for TB and VA. Next, you do the same for B. You do the same for B. Pull the B free body diagram. Pull the principle of linear impulse and momentum. Same, but you change V to B. Change the V to VB1. Momentum before, impulse, momentum after. So we again release from rest. B also start from rest, 0. Look at the free body diagram. What generate the impulse? As long as there's a force in the free body diagram, force multiplied by time, it generates impulse. There are two impulse here, W and T. So TB 6 seconds, W mg by time 6 seconds, M for B is 5 kilogram, VB2. So again, you get another linear equation. TB equal to something VB. You have two equations now. You have two equations. Solve these two linear equations. You have three equations. You have two unknown. TB, you have three unknown. TB, VA, TB, VB. Now, if you do not do the simplification using Pulley free body diagram just now, you will see TA over here. You will see TA over here, and you have 4 unknown. So you can you can simplify the equation of TA equal to 2TB in this equation, and you have three unknown here, TB, VA, TB is another one repeated. So TB, VA, VB. You have three unknown, two equation cannot solve. You need to find another equation with the kinematics using the rope. Just now you have a 2VA equal to 2 minus 2VB. So you have three equation, three unknown, then you can solve simultaneous equation. Okay, I don't need to teach you how to do simultaneous equation, right? You substitute this one here, then you solve. 1 minus 2 or 1 plus 2 or something. Then you solve. Okay, so if you substitute, you get VB equal to something. I give you the answer, 35.8 meter per second going down, positive. Tension cable, tension in the cable B, it is here, will equal to 19.2 Newton. From TB, you know how many is your TA. TA is double of TB. Oops, sorry. Okay. Then from here, you know what is the acceleration of, the velocity of A. If the question asks you the velocity of block A. From here, you substitute inside here, you find what is your VA. Okay, any question for example 3?
No, sir.
I hope it's clear. All right. So if no question, I see you guys tomorrow. Then we will hope you can conclude chapter 4 by tomorrow. Right? Okay, see you guys tomorrow. Take care, everyone.
Thank you, sir.